Welcome to the YourTown television program, sponsored by the Naval Postgraduate School Foundation. I'm your host, Lyla Englehorn. NPS has a reputation for bringing fascinating people to the Monterey Peninsula, and today I'm happy to welcome Kristen Tsolis to the program, Naval Postgraduate School Defense Analysis Department lecturer. So tell me a little bit about your background.
About my background.
Yeah.
So
how did you start? Where did your career begin, and what twists and turns did it take?
Oh goodness. I come from Connecticut.
Oh, okay.
And so I went to college without any view of computer science at all. I was very focused on history and law, and I was working with the National Archives for a few years. And I left the country and was living in Japan. I was teaching in Japan for a while. Mm. And for those who have lived in Japan, they know that after a while, you're always seen as a foreigner, and I thought it was maybe time to come home.
Gives you a different perspective.
Gives you a different perspective. Yeah. I really enjoyed it, and it was time to come home. And looking at grad schools, I realized that there were more people in Japan who knew about the West Coast than I did. So
it's a big country.
It's a big country.
Yeah.
So I decided to come to Monterey, to Middlebury Institute.
Oh, okay.
And pursue my graduate degree. So when I left the country, I should say before that, I was very interested in what was happening with the internet. That it was blocked off from me in college because unless you were a computer science major, you were not allowed any kind of access to the internet. And when I came back in the country, the internet happened. There was this explosion of browsers and search engines, and people were using email, and it was very exciting. Yeah, it was all exciting. Yeah. And this was 1996, 1997.
Yeah.
So,
which doesn't seem that long ago.
Which doesn't seem that long ago.
Right.
Yeah. So so a lot of the research I was doing at Middlebury was very policy centric, but I realized that more and more of my interests were in looking under the hood about how these technologies were working.
Interesting. Because
oftentimes, and we could see it today, policy is driven by what the technology allows it to do. So, and we can rail against that technology, but there's only so much control over it that we do have.
And policy injects the human element.
Indeed.
How as humans interact with that technology tool.
Yes, but understanding how you can forge policy requires knowledge about how exactly the technology works.
Oh, absolutely.
Yeah, so I spoke with a professor at NPS, and we bridged the schools. I was the first student from Middlebury allowed to take a class at the Naval Postgraduate School.
So that's how you got into the Naval Postgraduate School.
Yeah, so I took a lot of classes. I took more classes. And when I graduated from Middlebury, someone at NPS heard about the research I was doing and said, would you like to come work with me? And so it all kind of unfolded from there.
Oh, fantastic.
Yeah.
So in your role at Naval Postgraduate School now, what do you do?
I do a few things. One of them is that I am the director of an open experimentation lab called the Robo Dojo.
Oh.
Yeah, and I teach in the Department of Defense Analysis and do research there too.
Okay. Yeah. What do you teach?
So I teach a few things. One of them is I teach students, well, in the classroom I teach students how to collect, analyze, and use geospatial data. And so that's, for those who know, that's GIS. And so how is it that we can use aerial platforms to collect that kind of data? How is it that we can come to conclusions about what's happening over terrain? So those are very fascinating questions to me, research-wise. I also, because of my background more in computer security, because all of the questions I had policy-wise and technology-wise were around privacy and technology. So I also co-teach a class that's on computer security, and I teach in the Robo Dojo. Yeah.
So the Robo Dojo, tell me more about that. What is it? What do you do there?
So the Robo Dojo is an open experimentation space at the Naval Postgraduate School, where it's a multidisciplinary space. Anyone on campus can come in and learn more about rapid prototyping and about robotics. So we try to make these areas as accessible as possible because when people first start looking at rapid prototyping and robotics, there's a little bit of intimidation about it, especially for people without technical backgrounds.
Right.
And what we're trying to say is this is not as hard as you think.
Yeah.
You know, you can take the gear that we have in this lab and you can build your own home security system. And it's not hard. If you need to prototype something, you can make it yourself, and it's really not that hard. So there was a time, you know what the Homebrew Computer Club was?
No, tell me about that.
So the Homebrew Computer Club was this group. You had a whole bunch of computer visionaries who were starting up these computer companies, who were building computers out of their garage. And because all of these parts came to a point where people could build their own computers, but we're at a point now where people can build their own robots. People can use sensors and use actuators. They could take raw materials and they could build things that would completely surprise them.
In their garages.
In their garages, yeah. For a very cheap amount of money. And that's really important too for people to understand, is that these things are no longer rocket science. If you really look under the hood of what the technology is doing, it is rocket science, but for people as users, it's not.
We can build a rocket.
We can.
Yeah. And pedagogically, tell me a little bit more about the learning that happens when you actually get your hands dirty and do, rather than read and lecture.
So certainly there are fantastic classes at NPS that focus on learning. Some of these classes do not have this hands-on learning aspect. And indeed, we were talking a little bit earlier that there's a lot of learning with your hands that occurs when you allow students to do that. So one great example is, we'll go back to rockets. Right?
Okay.
So a few years ago, we had these students in the lab who were building rockets to be launched in the Mojave Desert. And so they started out just with the requirement, which was to build a rocket and to track where the rocket goes. So they knew that they had to build something that would fit inside the rocket that could hold the basic electronics for the rocket itself. So they started out building this one prototype, and then they realized, wait, this is a little bit too heavy, center of gravity's off on the rocket, so let's build another one. We're going to shift where it is, change the design a little bit, but wait, we can change the materials and make it lighter. So there's the next loop. And
they wouldn't have known those things unless they tried it and actually built it.
Yes, so
I think that's fascinating.
Multiple prototypes where they honed in closer and closer to what they needed, and that was really gratifying.
Excellent.
Great rockets.
Good, good. So the Robo Dojo as a space, would you call it like a maker space? Or
so there are lots of words that people use for these kind of spaces, and you see institutes of higher learning and also elementary schools building up these types of hands-on maker labs. You can call it maker lab, you can call it maker space, fab lab. Some people call it hacker spaces, but you're seeing this proliferation of these types of spaces in all types of learning environments. So definitely an experiential learning space.
Experiential learning.
Yeah.
Okay.
So, it's interesting because as we see they don't get younger, we get older, but as we see these new generations of students who come through NPS, they are becoming less and less likely to be those people who can sit through a quarter and listen to a professor talk for 2 hours. They're used to looking at YouTube and figuring out how to do something, or teaching themselves. So how is it that we could accommodate these people who are used to learning on their own? Yeah. With still having this very valuable classroom learning experience.
Absolutely.
How can we meet them where they are?
Fascinating space, the Robo Dojo. How did it start?
So the Robo Dojo for a long time was the twinkle in the eye of a bunch of systems engineering professors. Yeah. And at one point, one systems engineering professor and I sat down and we were talking about the research we could do. And this came up where he said, we've been talking about trying to get the space up and running. And I said, I want to do that. And now at the time I said I want to do that, I didn't realize that I would be running the space. So
Careful what you wish for.
Careful what you wish for. But it's been a really great ride, and it's been fascinating to watch as the space has grown, because though my title is director of the lab, as I say to everyone who walks through the door, that's kind of a misnomer, because the lab is really a community-run lab. It's very much of a grassroots effort where the students come in and the faculty come in with research questions or technology they want to learn about, and we incorporate learning opportunities for them in the lab. The learning workshops, the tools that they might use, open space where they can experiment, and probably the most important, the most valuable thing that we offer is community, because it's one of the few places on campus where the students can reach across different departments. So they're not within their particular
their program or
discipline.
the curriculum.
Yes, they can break out of that. And so you might have an information sciences student who meets up with a physics student, who meets up with a computer science student, and unless people just happen to be neighbors in La Mesa, you're not really going to have this kind of mix of students.
But that diverse perspective on a problem or problem space, I think, brings really robust outcomes.
Absolutely.
And I understand you're also a member of the MPS design thinking community.
I am.
And tell me a little bit, in your own words, what does that mean, design thinking?
So design thinking is a different approach to research from my perspective. There's certainly the type of research that says, let's look at this question, let's think statistically about how we might meet like this particular question, let's have hypotheses, let's test the hypotheses. But design thinking is more saying, well, there's a problem and there's a set of requirements, and how exactly could we meet the requirements? So the Robo Dojo allows people to think iteratively about how exactly those requirements might be met.
That makes sense.
Yes. So so how we fit into the design thinking work at NPS is thinking about allowing these hands-on experience for prototyping and iterating over solutions that might meet the requirements, and the requirements that might be evolving or that might be revealed over the course of
there's learning that goes on within that process. A lot of times traditional research, you think of, you have a research question, you do your research, you run your stats, and you propose your answers. And in the design thinking process, it seems like you start with a design challenge, just looking at a vast problem space, and within that work you find what you're solving for. Then you prototype and test your solution, and that solution may change over time.
Absolutely.
It gets a little messy, do you think?
Yes. Yes.
And I also think a value of the Robo Dojo is bringing that diverse group of perspectives, not just from a single discipline or a single curriculum, but bringing a bunch of people together, that community you talked about on a problem space.
Indeed, we had a group of students just a couple months ago, and there was a call sent out where someone said, there's this Hack of the Drones event that's happening in Texas.
Oh, I heard about that.
Would anyone like to participate? And it was a crew of students just that happened to be hanging around the Robo Dojo that said, okay. They had all met each other. They were from different departments. They had no preparation for this. They showed up. There were corporations there. There were universities that had prepared for a long time, and they ended up winning.
That's fantastic.
Yeah, so there's something very valuable about that just allowing students from multiple disciplines to get together and experiment.
Because they all have a unique puzzle piece.
Absolutely.
And when you put it all together, you can make a fantastic picture. Interesting. So where do you see the future of the Robo Dojo? What do you want to see in the future?
So the future. Where I think that we're going is that we were just talking about how these students increasingly are becoming students who can teach themselves. So it's also a question for the MPS campus. How do we as a campus meet these students where they are and allow them to learn in a different kinds of ways depending on
in a way that may be more effective for them.
And more effective, absolutely. So I think part of what we will do is think about how we can be incorporated more into the academic programs at NPS.
Okay.
And also it's hard to know where we'll go because there's always new blood and new research that comes through. So it's
really community driven.
It's very community driven, and what we do changes on a quarterly basis.
So you're a nimble program.
We are very, very nimble. A very low budget, because we really don't need a huge budget, and that's one of the great benefits of this type of lab. A very low budget, very nimble, multidisciplinary space.
And it sounds like the most important piece of your program are the students.
Absolutely. Yeah, the students volunteer to teach. It's not as if it's just the faculty who's coming in. It's the students who are saying, I want to learn about this thing, and I now have learned enough that I want to share what it is that I know, and I'm now not just this one person in one department with this interest. I now am finding these onesies in other departments and coming up with a community around this particular technology.
And I remember in my graduate work, you learn differently when you're put in the role of instructor. When I was a TA,
absolutely,
I learned econ in a different, deeper way when I had to answer the questions of others. And it seems like that provides our MPS students that opportunity.
Absolutely.
What sorts of workshops do you teach in the Robo Dojo? What can people get involved with?
So there are workshops that address the rapid prototyping aspects. So for example, laser cutting and engraving, how to design for the laser. There's 3D printing, how to design for a 3D printer. There's soldering, and we have a circuit board printer, so people can print and design their own circuit boards.
Really?
Yes, they don't need to send their designs out of the country. And so there are multiple benefits there.
Yeah.
One is that, again, you can iterate over designs very, very, very quickly within that kind of space. And the other is that you don't have to wait. So, for example, I don't have to send my circuit board design to China to get printed and then wait a couple weeks for it to come back. It's there. It's there within moments. So we have workshops around technologies of interest. So we have students teaching classes on software-defined radios. We have someone who's a safety officer on campus teaching a workshop that's all about using solar power in your house. So,
wow. Okay.
So it's all of these technology-related questions that bubble up around that. Around the students, and once they kind of attach themselves to one community or one particular technology, then it's fascinating to see them grow from there.
Absolutely. And ant weight battle bot competitions I've also seen happening near the Robo Dojo. My kids love the movie Big Hero 5, 6.
Yes. So we have ant weight combat robots, absolutely. And then for people who aren't interested in seeing their robots get destroyed, we have also a session that is, we're actually hosting very soon. It's all about teaching people how to build their own RC plane with laser cut foam board parts and very, very cheap electronics. So again, teaching people that these things are not as hard as they think they might be. So remote controlled airplanes are actually quite easy, easy to build and maybe a little bit harder to control if you don't have a good sense of direction.
Right.
Yeah.
But they have the opportunity to really get hands-on and try it themselves, and you learn by doing that.
Yes, absolutely. So we have basic robotic sets within the lab that people can experiment with, so that they don't find those robotic platforms as intimidating. And it could be that we get the students to a space where they feel more comfortable considering taking more advanced robotics classes at the Naval Postgraduate School.
Well, that is fantastic. I'm really glad you came in to join us today.
All right. Thank you very much.